Okay, voices off. Look over at the sideboard today. Look over at the sideboard, everybody. Look over at the sideboard, everybody. Look over at the sideboard, everybody. Feel like a broken record because not everybody's looking at the sideboard. Okay, if we look over at the sideboard, thank you. SWBA, what's SWBA stand for? Students will be able to identify and use properties. Sorry, that's geometry. Excuse me. Identify parallel perpendicular lines by their slope. We're going to talk about what parallel perpendicular lines are, and we're going to talk about their slope. Excuse me, I started reading geometry. That was not with you guys. Okay? Not another job. So 5, 6, we're covering parallel and perpendicular lines. Have you guys heard of these before?
Sure.
I'm actually asking.
I mean, you just told us, so yeah.
Okay,
Ask
so
right now.
have you heard of them before today?
Yes. Parallel and perpendicular line.
Parallel
Okay.
are like parallel parking, so it's like that.
Parallel straight.
And then lines
That
never
would never
touch.
touch.
Okay, so I heard some good things. I heard parallel. You don't have to write these down. I heard parallel are lines that never meet. So I heard lines never meet. Ooh, maybe if I can spell never correctly. Electric boogaloo. Okay. The lines that never meet. And someone said, hey, they're kind of like straight. They go straight. So there are two lines that never meet, and they go straight. Can we think of an example?
Parallel parking.
Okay, parallel parking. So if you're parallel parking, then the street's like coming along here. You know, you have your lane over here, you have a lane over here, and you have your car. Okay, we'll pretend that this is a car. Okay, it's a pretty good car.
What a beautiful car.
And so what you're doing is you're currently parallel to where you're parking, and you back in. So currently you're parallel with where you're going. Okay, so that'd be an example. What about railroad tracks? Railroad tracks. Will railroad tracks ever meet? No, that would be pretty bad if they did,
Wait,
right?
but they'll go like this, and then the thing opens up, so they actually do.
Okay, so they'll meet other ones, but the sides of the track never meet. So like they might meet other railroad tracks, but the tracks will never meet themselves, right?
Oh.
Those two on the opposite side are going to be parallel. Good question. Okay, the sides of one set of railroad tracks will never meet. Okay, or this could also be like a ladder. Okay, this could be like a ladder. The two sides of one ladder will never meet. Okay.
If you hold out your hands forwards, they're never gonna meet.
Okay. Hold out your hands
That's
forward,
you.
they're not going to meet.
Yeah.
Okay, but if we go this way, they might. But if we go straight forward. Okay. Those lines over there, if you look at my sideboard with the tape, those would be parallel. They're never going to meet, right? If you keep going on forever, or assuming at least I got them straight. Okay, the stripes on a flag would be parallel. Look at any of the flags to know that. Okay, they're never going to
The
meet.
tiles.
The tiles will be running parallel to each other. Okay, so lines with parallel tiles. Okay? Hey, so perpendicular. Hey, Graydon said something good. He said, hey, perpendicular. Wouldn't that be the ones where they only cross once? They do only cross once, but they cross in a very specific way. They cross in a very specific way. Well, lines go on forever, so they don't have a middle. Is the thing. That's a good thought, though. But they go on forever, so lines don't have a middle. They cross.
Wait, what?
Lines go on forever. They're infinitely long. So if it's infinitely long, there's no middle.
But there's like right there.
That's not a line. That's an if we
That's a
pretend
line
that they
segment.
go on forever, so we have to pretend
That's
because this ends. So it actually would be considered a line segment, line particle.
That's what I just said.
But anyway, continuing on. Okay. These are going to be lines that cross at this kind of an angle. What kind of an angle might that be?
90 degree.
A 90-degree angle.
Acute angle.
So they cross at a 90-degree angle.
Oh, sorry.
Okay, this is bringing me back to like geometry.
Class, you had a lot of talking. You need to cut it out. Thank you. cross at a 90-degree angle. That's how they cross. They don't cross at any other kind of angle. It has to cross, and it forms almost like kind of like a T. It does kind of form like a T there, right? Okay, this is like an upside down T. Okay, it's like a T pose, you know? Okay, that could be perpendicular. Okay, what about some of these tiles? If we look up at the tiles here, we have these metal bars that run across the ceiling, right? Do some of those meet at a perpendicular? To be perpendicular, they intersect to form right angles, don't they? Okay. Okay. What about the parts of this blue, the union of the flag, the stars field of the flag?
Yeah.
Is that a right angle?
Yeah. Sure.
Yeah, it looks like a right angle to me. Okay. What about on this cabinet? This part runs straight up and down. This part runs straight left and right. Are these perpendicular?
Sure.
Yeah, they look perpendicular to me.
Does that mean it has two right angles? Because it's on that side and that side.
Hey, that's a good question. How many right angles will this have? Well, it'd have a right angle here, it'd have a right angle here, and actually it keeps going this way, and it really has 4 right angles. All of them are right angles. Okay? Okay. So, if we have these parallel lines, actually one thing I want you to write is I want you to write parallel lines never meet and perpendicular cross at 90-degree angle. I want you to write those 2 things. If you haven't written it, I want you to write parallel, lines never meet, perpendicular, they cross at a 90-degree angle. That's what I want you to write from this if you haven't already. That's why I want you to write those 2 things. Parallel, lines never meet, perpendicular, cross at a 90-degree angle.
I write down everything that you write down unless you say not to notice.
Okay. Sorry, I don't have control. It is.
It's like cold everywhere. What happened right there? Looks like you went to a fight.
Yeah, you should see the bear.
Oh. Oh, yeah.
Okay?
Oh, he probably kicked off his roommate.
Okay, so continuing on.
No.
So parallel lines will never ever meet. Perpendicular lines meet to form a 90-degree angle. So they cross in a special way. Thank you, Grace. That was very good of you to do. So we have these parallel lines. These lines will never meet. Let's find the slope of these lines. If we're finding the slope of line AB, how can we do it? Rise over run. How much does it rise here?
1. Oh, wait.
How much does it run?
Sorry.
So the rise over run would be.
4.
Do we agree that these lines are parallel, by the way?
Yeah.
Okay, they'll never intersect. So the slope of this line is 3 over 2. Let's find the slope of CD. How much does it rise?
3.
How much does it run?
2.
What's the slope? 3 over 2. What do we know about these slopes? Parallel lines will always have the same slope. Write this down. Parallel lines have the same slope. I'm going to write this part down. Maybe we put a big old star next to it. By maybe, I mean put a big old star next to it. Parallel lines have the same slope. Just Ben. Can you wait 10 minutes? Go ahead and fill out fast. Okay. So in these lines, how can we figure out which 2 of these lines might be parallel? Solving, and we would look at what? We'd look at their slope. What would we want to know about their slope?
3x plus 2.
What would we want to know about their slope for them to be parallel? They would have to have what slope?
Same.
The same. So you want to see if their slope is the same. So you would look at their slope. Okay, so what's the slope of this line?
X or 3x.
Just 3. What form is this line in?
Point slope.
Standard. How can we find slope in standard form? this is ax plus by is equal to c. That's what standard form is.
Negative A over B.
We can do negative a over b. What's negative?
Confusing.
What's a?
1.
Okay, so negative of 1 is,
Negative 1.
what's b? So the slope is negative 1 over 2. Okay, we can find the slope of this line. Well, what is the slope of this line?
So they would be there.
So this is parallel. These two are parallel, right? Because they have the same slope. What's the slope of this line? Well, what do we need to do first?
It's 3.
What do you say after that?
It's 3.
What do you say after you burp?
I said pardon me.
Okay, thank you. I didn't hear you. What's our slope of this line?
3.
Is this one parallel with another line? Which
Parallel
one?
to the first one.
That first one. So if we've already starred these, how could we signify these in a different way?
A big bullet.
Draw a line.
Okay, we can do a smiley face. We can draw a line. I heard that one too. We can draw a line connecting them. We can do a smiley face.
A bullet point.
I told that
Okay. But does it make sense that we would do the same on each of these to decide what we knew? Okay. But these are a different kind of 4 and a different kind of 2, so you don't know right away. You can't just look at this and say, you can't just look at this one and be like, I know the slope is this, and so it has to be parallel to this. You have to find the slope. So you can't tell just by looking. You have to say, I know what the slope is. It is this. Because we're not even worried about the 4. We're not even worried about this 4. We're worried about the slope. How else could we have found the slope of this bottom left one if we didn't know negative a over b? Changes the slope intercept form, so we solve for what variable? Y. We can also find the slope that way. So if we find the equation of a parallel line, I want you to, so if we write the equation of a line, that means we're writing an equation of a line, parallel to this line, that goes through the point 1, 3. I want you to write this, and this. So I just underline those two things. I want you to write those two things down, please.
Why is it so cold in here?
I don't know.
This is freezing.
Okay, so it's parallel to this line, and it goes through a point 1, 3. Well, if it's parallel to this line, what does that tell us?
It's got the same slope.
It has the same slope. Parallel lines have the same slope. What's the slope of this line?
2.
How do we know the slope is 2?
2x.
It is with the x. So this slope is 2. So the slope of the line we want is what?
2.
It's the same. So we have the slope, and we're given what else? Point. So what are we going to use? Point slope form. Remind me what point slope form is.
Y minus y1 equals m parentheses x minus x1.
Very good, Grace. So we know to use point slope form because we're given point and a slope. Someone help me plug this in.
Okay, so do we plug in the 2? Because
Yep.
what if it's not that way?
But we do know because it's parallel to this line, so we know it has the same slope.
Oh, okay.
So we know for sure.
And then parentheses x minus 1.
Okay, and I'm going to have us continue solving this one for slope intercept form. And have us continue to solve this. What's our first step in solving this for slope intercept form? Distribute. What's 2 times x?
2x.
What's 2 times negative 1?
2. Or negative 2.
And then what's our last step in solving for y?
Add 3 to both sides.
Add 3 to both sides. Y is equal to 2x plus 1. Thank you, Grace. We wrote the equation of the line that's parallel to this one, and it goes through this point. Questions on that?
Okay, wait. So, what if like they're trying to make us like tell if it's parallel or not? Then how do we put in the slope?
If we're just trying to tell if they're parallel, we have to look at their slopes. So we'd have to be given them
No, but what
equations.
if we're given that? Like,
If you're given this, then you find the slope, which is 2, and you plug it in, like we just did.
but what if it's like not parallel? And you plug it in.
We have to know the slope. So if it's parallel, it'll have the same slope. There's another scenario we'll get to in a minute, otherwise we said it has this slope. So either be told it has this slope, or it's parallel, or it's perpendicular, as we'll get to in a moment. So if it's parallel, the slope's the same. If we're given a slope, we use that slope. If it's perpendicular, we'll get to that one in a second. Okay. Perpendicular lines, we talked about those a little bit. These lines, these look to intersect at a 90-degree angle. Let's find the slopes of these lines. Line AB, rise over run, 1, 2, 3. Rises 3, runs 1, 2. What's the slope of this line?
Wait, the other one's gonna be negative.
Let's look at CB. Rise over run. It rises 1, 2. It actually goes -2. It falls 2. And it runs 1, 2, 3. What's the slope of this line? What do we notice about these two? They're opposite signs. This one's positive, this one's negative. They're the negative reciprocal. This one is 3/2, this one's 2/3. Reciprocal means you flip it. And they're opposite signs. This one's positive, this one's negative. And these lines were perpendicular, right? Well, perpendicular lines will always have opposite reciprocal slope. Write that top part down. The slope of a perpendicular line are opposite reciprocals.
Are we gonna start it?
Yes, go ahead and star that too. Thank you for asking. So opposite reciprocal, opposite sign, reciprocal is when you flip. So hey, what would be the opposite reciprocal of 3/4?
-4/3.
Okay, so instead of being positive, it becomes negative. Instead of being 3/4, it becomes 4/3. Someone other than Justin, tell me what the opposite reciprocal of 8 would be.
-1.
Very good, -1/8. This is like an 8/1. You reciprocate it, 1/8, make it the opposite sign, this becomes negative. Okay? If we write an equation of a perpendicular line, it's the same thing as we had before, right? But now it's perpendicular instead of parallel. So what's the slope of this line that we're given?
-3/1.
No, what's the slope of the line we're given?
Oh, 1/3.
1/3. So if it's perpendicular, what would be our new slope?
-3/1.
-3/1, or just -3, right? And we're given a point. So this is the other scenario I was talking about, Grace. Does that make more sense? Okay. Can I get a volunteer to pass these out real quick? Okay, thank you, Grace. Okay. I want everyone paying attention to this. On number 1 through 9, we'll do the evens. And then on 10 through 21, I want you to do all of them. So write that down or take a picture as class is about to end. Write that down or take a picture with your phone or something. That we're doing 1 through 9 evens, 10 through 21 all. That will also be on Google Classroom. Thanks, Grace. I appreciate it.
Yep.
This will also be on Google Classroom. Hey, what can you do if you're struggling with what to do on this homework?
Watch the video.
Watch the video. If you're saying, hey, I'm confused about the perpendicular line part, go back to this part right now. Yes, great. Have a great day, everybody. Thank you.
What?